Hi friends! Are you a college student looking to pursue software after graduation? Well, you've probably heard of this thing called the technical interview, a terrifying interview format where a real engineer is going to ask you to code live in front of them and explain it as you do it. It's a way that our industry uses to sort of assess new talent and give you essentially a midterm quiz right there on the spot. My name is Casey, and on this channel, me and my best friend Kim make content for college students like you to make sure that you're extra prepared for that transition to the tech industry after graduation. And so in this video, I'm going to talk about what this thing, the technical interview, is, how it came about, and go through the specific parts of the interview and how that engineer is going to want you to answer their questions, even though they might not phrase the question in that way. And then finally, I'm going to finish up with a list of all the topics you should feel extra comfortable with before walking into that interview and some tips for how to get started on studying. So where did this technical interview come from? Well, it was actually invented at Microsoft by Bill Gates. He had the idea that, hey, I love doing puzzles, and I bet if I ask somebody to do a puzzle in front of you, it might tell me something about the way that they solve problems and ultimately the way that they write code. We have now debunked this. We know that doing puzzles actually has very little correlation with how good a software engineer you are. And so instead of doing puzzles, now we have changed the format where in either 30 minutes or an hour, an engineer is going to present you with a problem, and you're going to be asked to write executable, complete code to solve that problem right there live in front of them. Now, we do this partially because companies love data, and it feels like this objective measure, right? Like if somebody can code in an interview, well, then they can probably code on the job. And in fact, that's what Google really was trying to research when they picked up this format. And now they're sort of the thought leader in the industry when it comes to what level of difficulty, what type of problems, et cetera, et cetera. And so when you say technical interview, most people in the tech industry will think that that's a very specific and rather standardized format. And as you'll see in this video, there's some very common patterns that you can be prepared for. But the unfortunate answer is that they might not be as standardized as we all believe them to be. And there's actually a lot of sort of unsaid expectations that come with these interviews that us in the industry all know about, but those of you that maybe don't have family, friends, or community already in tech just don't get to hear about. So my goal is to make sure that at the end of this video, you know what you need to do to prepare, what you need to do to answer all of the questions, and exactly how to shine best in that interview. This is an outline of the typical recruiting process for any software engineering company. You have to kind of start by meeting them. Typically, you submit an application. Then there might be a few different places along the way between your application and you finally accepting an offer where that company is going to try and assess your technical skills. Now, if you are currently a university student, one of those stages might be what we would call an online coding challenge, which is typically sent via an email, and you get some amount of preset time, say 90 minutes to 2 hours, to write code to some sort of little problems. Now, this is really just the way that these companies are scaling across so many student applications, because the unfortunate reality is that if you all go to school together, your resumes kind of look pretty similar. So this is just another way that companies can meet as many people as possible and start to narrow the field down. What you should know about these coding challenges is that they typically do come with a certain amount of test suites included. You absolutely need to pass every single test in order to likely move on to the next stage. But you should know that there is also probably a host of hidden tests as well. So just passing the test that they expose to you is probably not enough. The other thing you should be aware of is with these coding challenges, like I said, companies are trying to use this to scale out their applications. I've seen companies show up to conferences and send these out to every student attendee at the conference, for example. So sometimes just passing all the tests still provides them too many students compared to how many interview slots they have. So sometimes companies will start to distinguish between students based on the time it takes a student to complete that exam. Not because they actually care that you're a super fast coder, but that's just the only other piece of data they have. So if you're doing these things, One, I suggest treat them like practice. I know they come up a lot. Just think of it as another way to practice coding problems. But make sure that before you hit start, and that will start the clock, that you feel you have all the time in the world to focus on just that thing. You don't want to be getting up and going to the bathroom or getting a snack or something like that, because they won't tell you, but chances are they might be using the amount of time you spend solving the problem as a way to decide who goes on to the next round. After the coding challenge, there might be another interaction with your recruiter that students often ask me if it's an interview, but sometimes you will have a phone call specifically not with an engineer, but rather with your recruiter. And we often call this sort of the recruiter screen, or really what this is that recruiter speaking to you before they spend an hour of an engineer's time on an interview, making sure that you are just the right fit for the role. Are you somebody that's only looking for software and they're only hiring for hardware? Well, they want to make sure that they're not going to waste an engineer's time on the next round of interview. So after you've done your coding challenge and maybe you've done your recruiter screen, we're finally getting into the part of the recruitment phase where you're going to be actually sitting down with an engineer, and that engineer is going to be asking you questions in the coding interview. Now, this typically comes in 2 rounds. There's usually a first round, or what we refer to as the technical screen. And the idea of this interview, which can range, sometimes it's as small as 20 minutes, sometimes it's as long as an hour. But the point of this interview is to assess whether you are likely to pass a later, more in-depth technical interview. Interviewing candidates is really expensive, especially when you factor in not only the time it takes to set that up, but the fact that we're taking that engineer's time away from building product. So companies are constantly trying to make sure that they spend their interview slots on candidates most likely to pass the full interview. So you'll find with the technical screen, it's just kind of a mini version of what we're going to get into more detail in as far as the technical interview format. Usually there's one screen. If you pass that, then you move on to what might be referred to as the second round. Once upon a time, we called it the on-site interview because you would physically fly to the site where you would work so you could get a sense of the building, meet some of the people, and it would be one long day of maybe 3 to 6 hour-long interviews, each one with a different person. And within that collection, probably at least 2 or 3, but maybe even more, will be technical in nature. Now, in the post-pandemic time, we might not be physically flying, but we still apply the same idea of the second round being a collection of maybe 3 to 6 interviews, some subset of them being technical, maybe one of them is more behavioral or about sort of like company culture fit type of thing. But that technical screen is going to be a miniature version of the technical interviews that come in the second round, specifically to make sure that hey, like if you're going to come on site, we want to be reasonably sure that you can code well enough to pass typically a more complex interview. So you should know that the screen and the on-site have almost identical formats, but you'll find that typically we use things like arrays or strings or linked lists in the screen, and we might have more time to get in more detailed or difficult topics like graphs or hashing or inheritance in the longer form interviews that follow after. Let's talk about this actual format of a singular technical interview. So that interview might be 20 minutes, or it might be 30 minutes if it's a screen, pretty common. But other than that, traditionally they are about an hour long. In that hour long, you're usually going to be speaking to one other engineer. I was that engineer for many, many interviews. That engineer can be anyone from a recent college grad to a senior hiring manager. It's kind of whoever signed up to interview for the day. Now, they are going to have a few different parts, and this might vary, but you'll find these 4 parts come up very consistently across companies and across interviewers. So first, you're going to have some level of introductions, something to kind of break the ice a little bit so that they can learn about you and what you're looking for. Then they're going to ask you a behavioral question where they're going to ask you about a previous technical project you've worked on. And they are looking for some specific types of descriptions we're going to go over in a few slides. Those 2 things together might be about 10 minutes, maybe 7 to 10 minutes in an hour-long interview, leaving the vast majority of the time to be spent on what we would refer to as the coding question. The coding question is where the engineer is going to provide you with a prompt. You're going to ask a bunch of clarifying questions. You're going to talk about your plan, and then you're going to write the code to solve that problem right there in the interview, and then make sure you test it to prove it actually works. Now, there is a fourth part that people often don't realize is still part of the interview, and your interviewer will likely tell you about this at the very beginning. Often, some of the first things your interviewers tell you is they're like, hey, we're going to get to know each other. We're going to talk about a project. I'm going to ask you to do coding. And then I'll leave some time at the end for you to ask me questions. While it might sound like, oh, that's so nice, just a chance for me to get to know the company a bit better, this is actually totally part of the interview, and the questions that you ask and the way that you express your enthusiasm and curiosity for the company really matter. So you want to make sure that you respect time for your questions as a full part of the interview, even though it often comes after the coding section when you can be really tired and all you want to do is get out of the room. Let's dive into these sections in a little more detail so we can talk about what they want us to hear from you specifically at each of these moments. So, in terms of introductions, yes, we are talking about a technical interview where we are likely looking for somebody that is going to write code the majority of their time on the job, or they're going to be working with people who are writing code. This isn't so much a networking introduction as just a very brief way to break the ice and then give your type of elevator pitch as to who you are and why you want to work there. I say elevator pitch because you're probably going to get used to saying this, say, at every career fair or anytime you meet somebody and you're trying to apply. So you want to get somewhere between 90 seconds and 2 minutes of a, hey, this is my name, this is the school I go to, this is when I'm graduating, maybe this is the area of technology that I'm particularly interested in, and maybe like one big highlight that shows your passion from college. So mine might have been something like, hi, my name is Casey Champion, I'm studying electrical engineering at the University of Washington, I'm really passionate about education, and because of that, I spent most of my time at the University of Washington as a TA. As you can see, I sort of talked about who I am, what my passions are, and then demonstrated a little bit. You might find that even this is too long of an interview or introduction, and your interviewer might not even be that particularly interested in this moment. Do not take it personal. We are not a people that are well known for being super warm and socially capable, and you should be aware that your interviewer might be super tired from having done a ton of interviews back to back. Especially if you're at the technical screen portion, often they will have an interviewer come in and do like 16 interviews back to back to back. It's very common for interviewers to get tired and want to skip over this introductions portion. And so my best advice to you is keep it light, keep it nice and fun, and don't be too offended if they seem distracted. But the best thing you can do is just try to maybe meet them at their energy level and always show off that dazzling, positive energy that comes with being somebody at the very beginning of their career. The second section of your interview will likely be devoted to the behavioral question of asking you about a previous software engineering project. Now, it's a behavioral question because we're asking you about behavior of yours from the past that is going to help us predict what your behavior will be in the future. So in asking this question, what the interviewer is really trying to get at is, what's it like to be your coworker? What's it like to work with you on a technical project? So it does matter what type of project you pick to talk about, and you want to make sure that you have a few different options of projects you can discuss on your resume, especially if you're doing multiple different interviews in an on-site. You can talk about the same project in a few of them, but you want to make sure that when they come together and everybody reviews all of your different interviews, that you've demonstrated a couple different projects that you've worked on. Now, chances are they might open up your resume and pick which project on your resume they want to hear about, and you should know they're likely going to pick the one they associate with being most analogous to the job you're applying for. So if you're applying for a full-time position and you have a internship on your resume, they're probably going to ask you about that. Or if you're applying for some type of research position, they might ask you about your research, so on and so forth. Now, they also might give you the choice to offer up a project of your choosing by asking you something like, tell me about the most difficult technical problem you've ever solved, or tell me about the software project you worked on for the longest amount of time. And so again, make sure that you have some idea of how you would explain all of the projects that do show up on your resume, whether they're a job, they're a class project, or they're, sort of research or academic. You want to be able to answer some basic things about that project in terms of this discussion. Here is an example of the type of information you might want to offer up when you're first introducing the project you're going to talk about. Now, I know that you can get kind of ahead of yourself and it feels like tell me about a technical project is a complete question, but actually this is where you'll find a lot of variance across companies. What that interviewer might be looking to fill out on their review sheet could be totally different. I've worked at companies where what they were trying to assess was your conflict resolution strategy or your passion for technology. At some companies, it's about what is your debugging technique, or hey, we're specifically looking for people with experience in this skill set. Tell us about that Python project. And so actually, in this context, the best thing you can do for yourself is make sure that you have about a 90-second to 2-minute introduction for each one of the projects on your resume. And then after you give that introduction, pause and let the interviewer follow up with their own questions, because chances are they're just going to ask you the questions that they need to directly write on their sort of review sheet afterwards. So it's always good to make your interviewer's life as easy as possible. Get them on your side early. So some things you will want to mention in the initial sort of introduction of your project is what was the project? What was the thing you were building or solving? Where were you doing it? Was it at a company? Was it at a school? Is it a class project, etc.? What team were you working on? How many people did you work with? Did you have a mentor? What role did you play on the team? What technologies did you use? Please do list the language you coded in. Maybe, what platform were you using? Did you use a specific API set? All of those things, make sure that you do list them by name. Remember, you're talking to an engineer. They might not know each of those individual technologies, but you can tell them the level of technical detail of the infrastructure of whatever you worked on. And then finally, you want to be a real rock star. Make sure that you have some type of result from your project that will give your interviewer a sense of its scale. Something that gives you a sense of how many lines of code or how many users or how impactful the project that you did was. Maybe it saved people from a bad design down the line, or maybe it welcomed new users onto a platform, or maybe it saved other engineers a bunch of time, etc. So that will give your interviewer enough context, and then they're going to follow up with questions. And if they've been well trained, the questions they're going to follow up with are intentionally designed to get you what we would call off script. We know you talk about the same projects over and over and over again. We also know it's really easy in school to be a member of a group and maybe not be the most contributing member of the group. And so the idea to sort of, quote, get you off script is to get you to actually start talking from your memory and your experiences and not just the thing that you coached yourself to say because you were that group member just kind of hanging out in the back while everybody else did the work. In this context, you might also find that your interviewer will interrupt you and get really specific. Again, this is probably because they're trying to get at a very specific piece of information. Let them guide you through that flow. Try your best not to be offended. But one of the interruptions that we have been taught to do is if you use the word we too much, then your interviewer can't tell what was your specific contribution to the project. And you're in an interview. It's time to brag about what you specifically did in the project. And don't feel bad if your role wasn't the number one developer. It takes a lot of people to put together good teams. Maybe your role was testing. Maybe your role was helping do some of the design and the brainstorming. Maybe you did all of those things, but you kind of had a special leadership role, or maybe you kind of had a special sort of keeper of the peace role. Make sure you think about specifically what your contribution was, whether it was code or team dynamic, and speak to that as much as you can, and avoid just talking about what the overall group did the entire time, because it might come off like, oh, well, if the whole group did it, then you didn't really do that much. And you want to make sure that they walk away thinking, wow, this person is the best teammate. I can't wait for them to be my coworker. After the project discussion, it's time for what might be the scariest part of the interview, the coding question. Now, the coding question hopefully will take the bulk of the interview time. If you have a 30-minute interview, Usually will take about 20 minutes. If you have an hour-long interview, it will usually take about 45 minutes. In the 45-minute example, then you might find that initially the interviewer is going to present you with the prompt, and that prompt will intentionally not contain all the information that you need in order to solve the problem. Some engineers, like myself, think this is an unfair and unsaid requirement. Like, how do you know that we are intentionally not telling you everything and that you are expected to ask us questions? So you might find that there's some variance in the style to this, but when you are first presented with the question, there is a lot of things you need to do before you actually start coding. So again, make sure that you slow your brain down, you listen to everything that they say. If you have the option, maybe take some notes, like write down what the input or the output will be, and then start asking a ton of follow-up questions. In fact, there are 5 phases that you want to follow when you are approaching answering the technical coding question. We have created a nice little memory device for you, codes. C, clarify the question first. Ask all those follow-up questions. Make sure you know what they're actually asking you to code. What's the input? What's the output? Can I modify the input? Am I limited in what API sets I can use? What scale do I have to worry about? Not only do you need to know those questions to write the correct solution, but it also demonstrates to your interviewer that you do not just code on assumption, that you know what questions you need to ask in order to write really good code. So do not skip the questions. The second phase, O, outline your plan. Before you start coding, you need to make sure that you have a bit of a back and forth conversation with your interviewer about what you're actually about to code. Now, it's an outline. This conversation back and forth could last anywhere from, like 90 seconds to maybe you have to discuss it for a few minutes. And during this time, make sure that you are listening very closely to your interviewer for any suggestions or gentle pushes that they might be applying to the solution that you're proposing. Pretty much every interviewer will use an interview question that is either very well known in a database, if not very well known to them themselves, meaning it is almost impossible that in that moment you are going to invent a solution to this problem that they don't already have in the back of their head. And you should be aware that that's part of prepping for the interview, knowing what the solutions are. You should also know that often these solutions can sort of have different, we'll say, sort of expectations around them. For example, maybe you can solve the problem with a nested for loop or some recursive backtracking, but it's really inefficient. So that might get categorized as what we would refer to as a naive solution. Then maybe there's some, sort of like linear runtime solution where you just use a couple hash tables or something like that. And that might be what we would refer to as the acceptable level solution. And then sometimes there might be a third category where you can do something extra tricky. Maybe, instead of using a bunch of hash tables, you can use some dynamic programming, or you can use something really clever to make it even more optimized, and that would be the optimal solution. So when you're going through this sort of discussing your plan moment, pay attention, because often interviewers can't help themselves, but just try to figure out which one of those categories, which one of the solutions you're already heading towards. And so you kind of want to let them lead you towards one of the good solutions. You have this kind of back and forth. You want to give them that outline, a couple sentences, like what data structure are you using? What's like a really high level of the algorithm you're going to use? And then you're going to look for some amount of sort of go ahead indication from your interviewer. Not every interviewer will give you the most feedback. Some of them might just say, if that's what you want to do, go ahead, or let's get started, something like that. But you do want to kind of see that they're at the conclusion, or they have enough in their brain about what solution you're going after before you start coding. One, because that's going to make their life very easy. And in fact, I know many interviewers that just try to figure out what solution you're going to go after, and then again, if they've been interviewing for 8 hours, maybe they kind of check out and they don't notice that you wrote some bugs or even pay that much close attention to your code. They just want to see, could you figure out what it was going to be? So make sure that this part goes well. You should be aware that not every interviewer will interrupt you to make sure that you have a workable solution. Some will. Some will say, do not get started until you list a plan that they know will lead to a solution. Some will say, well, let's see how it goes, or why don't you try it out, that kind of thing. So it will vary, of course, but you want to make sure that that is intentionally a bunch of questions followed by a plan and a really important conversation with your interviewer, because this is when they're picking up your problem-solving skills, your ability to define ambiguity, your ability to sort of abstract, your ability to communicate, all of those types of things. Now, from the moment that the interviewer has given you the prompt, you've clarified the question, you've outlined your solution, it's time for step 3, develop your solution. Actually start writing code. Now, if you have 45 minutes to start doing your coding problem, that beginning part, try to keep it somewhere between 7 and 10 minutes so that you have like at least 30 minutes of the 45 to write your code. Also, if you kind of delay too long, the interviewer will get a little antsy and kind of expect you to move it along, even though I know there's a million questions and a million things to talk about. So when it's time for you to actually write your code, you may be asked to write it in a doc. You might be asked to write it in a notepad. You might be asked to write it on the whiteboard. You might be asked to write it on a legal pad. I've had all of those myself, so be prepared. Be prepared to write without your IDE. Be prepared to write physically by hand. Be prepared to maybe write at a whiteboard. Those are a little less common now in the post-pandemic days. Chances are it will be some type of video conference call where you have some type of shared collaborative coding environment, and maybe you even have a compiler, which would be really nice. But be prepared, you might not be offered those things. As you code, nobody's code in an interview is particularly beautiful. Nobody's code runs particularly linearly. It's very common for people to kind of get into their main control structures and then remember something and add it later, or find a bug and fix it later. But you should be aware that the code that you write is going to represent you often when you leave the room. You leave that code behind on the whiteboard, or they keep it in that document. Like I said, they're not going to expect it to be production level code, but do take time to give reasonable variable names. Do take time to use some indentation. Do take some time to maybe, organize your code in a way that's a little more readable. I'm not saying the most elaborate, but it's really off-putting when I have a student come in and they do no tabbing and they name all of their variables a single letter. It's impossible for me to read that code later. And also it just kind of feels like that's not the type of coder I want writing code in my code base. So do your best to balance these things. After you've written your code, most people will kind of turn their brains off. They just want to get out of that room as quickly as possible, but never skip the testing section. Now, I'm not saying you have to write whole long unit tests, but in the very beginning when you were clarifying, one of my favorite ways to clarify the question is to sort of list out a possible set of inputs and the expected outputs. Like, what happens if the item's in the middle of the list, the front of the list, the back of the list? What if the item is null? What if the list is null? Just some basic things so you understand what you're being asked to do. And if you wrote those down at the beginning, then just go back through and you can just verbally kind of talk through, oh yes, I can, walk through this test case, or oh, I can see it would pass this test case. I cannot tell you how many students find critical errors just because they took that little bit of time to actually test their code at the end. In fact, a hot tip, the thing that is most commonly missed is forgetting to update the current pointer or forgetting to return the actual value at the end of your code. It happens all the time. Stress brains do weird things in interviews, but give yourself a little bit of time at the end to do that reflection. And now finally, the S in code suggest optimizations. What that really is about is that in the coding interview, it's mostly completion that matters. Some companies care about speed, other companies care more about optimality, but your goal should always be to get to a working piece of code in as efficient a time period as possible. Now, sometimes that means that that naive approach first comes to your brain. Maybe it's the nested loops approach. It's okay to write that approach down, knowing it's not the most optimal. And then at the very end, if you've figured out what the optimal approach would be, if you just say it, If you're like, hey, I wrote all this code, but I just realized if I used a hash table, I could change this from an n squared runtime to an n runtime. When I write your review, I'm going to give you full credit for using the optimized solution just because you said it aloud at the end. So save yourself a little time to maybe offer some improvements or suggestions to see if you kind of grab those extra points at the end there. And then finally, now you really are done at the end of the interview. You cannot wait to get out of this room, but it's that sneaky requirement. It's time for your questions. Now, you can take this as a good or bad analogy, but you do kind of have to treat this like you're meeting and courting a new person in your life. You're building a new relationship. And the interviews are at the very beginning of this relationship. So you want to keep it light. You want to keep it softball. You want to give the interviewer an opportunity to talk about themselves or the company in a positive light. And that way, when the interview ends, the last view they had of you was something nice and lighthearted and positive, and that's the feeling that they have when you leave the room and then suddenly they have to write their review of you. This is not the time for hard-hitting questions where you really question whether or not that product choice was right or what's happening with their sort of like quarterly earnings. It's also not a time for rude questions. Now, these might not sound rude to you, but for example, you should never ask them how much money they make. And I personally never think you should ask, how did I do in this interview to that person? Other people have different feelings about this, but you should know from an HR perspective, there's actually legal issues around telling you about your interview performance. And so asking the interviewer those types of questions could put them in some hot water. And that's not the impression you want to leave right before you leave the room. Some questions that are great to ask are things that you can ask every interviewer and get a different answer to. You don't want to ask questions that you could easily Google or questions that the engineer won't know that the recruiter will know. Save those for the email later. Google those yourself. But questions like, well, what do you love about working here? What's your favorite project that you've worked on? What types of projects do interns work on your team? What's your favorite product that your company has released in the last year? Something like that gets them to be able to sort of reflect on their time, talk about their experience, give you a little taste of how they relate to their job. You should be aware that yes, companies do coach interviewers on how to answer this question. So you might not get the most honest answer, but again, we're playing the get to know you game. This is the time for the softball questions. Save all those hard-hitting, hey, I really didn't like what you guys did with that particular product over there, or hey, I'm really concerned about your work-life balance. Save those questions for after the offer. Now let's talk about the time leading up to these interviews. Students ask me all the time, how much studying should I be doing? What should I be studying? And the honest answer is it's gonna vary per person. But the way that you should think about it is preparing like you are for a standardized test. I always tell people you might be the world's best mathematician or the world's greatest writer, but the SAT or ACT has very specific types of questions and specific ways they want you to answer those questions. So you can't just go in blind. You have to practice interview style coding. Because also when we're asking you to write questions in an hour in front of somebody, it's not really similar to the way that you probably write code for your homework assignments. So you need to practice according to the environment. You need to practice according to the types of questions. So here is a list of things that I would make sure that you are actively reviewing leading up to your interviews. One, actually a really fun, simple one. Make sure you know something about the company that you're actually interviewing for. Now, if it's one of those bigger brand names, they will probably expect that you know what Facebook or Meta does. But if it's a smaller or medium-sized company, I cannot tell you how far the most basic knowledge about their products or culture will go. A real thing that happened to me was I said yes to every interview that I was ever offered. Sometimes that was for companies I'd never heard of. And once I totally forgot. I didn't even know the name of the company or what they did. I was just waiting outside. So I quickly opened up my phone and I Googled that company and I saw their headline on their webpage. And that's all I read. Just this particular tagline they put on their website. And when I went in and met my interviewer, that was like the first thing I said to him. I said, wow, I hear you're doing really great things. And I just repeated the company tagline. I got the job, and later my interviewer, who was my mentor, told me that I was the only candidate that literally had Googled the company. So just some basic stuff goes a really long way. For interviews in general, of course, one of the most important pieces of prep you're going to do is picking the language you're going to do your interviews in. If you are a college student applying for a general software engineering internship or full-time position, you are likely, extremely likely, to be able to do the interview in the language of your choosing. You should also be aware that your interviewer might not know that language, and that might be to your advantage. They might not notice if you make a mistake, but it also might be harder if they can't help you. When you're picking your language, you need to think of your language like your sword. It is the thing that is going to help you through this battle. You need to be one with your sword. It is so much more important that you pick a language that you know well and that you get to know your language well than having an array of different languages. In fact, as a hiring manager, anytime I saw a student list more than 3 languages on their resume, I automatically knew that everything after the third one was a lie. We just ignore that. So pick one language and go deep. And because most technical interviews are object-oriented in nature, pick an object-oriented language. For example, when I was doing research on interviews, we did notice that the language that often passed interviews the most was Python. Now, part of that is correlative. Students pass technical interviews more often than senior engineers because they're studying for them. Again, it's like prepping for the SAT, so you're fresh. And Python has a great set of APIs that actually make a lot of the types of things you're going to do in interviews particularly simple to accomplish. But Java, C++, C#, these are great object-oriented languages that get used in interviews all the time. And even though, like I said, Python's quite popular and it does well, if, for example, the language that your school has been teaching you in is Java and you've been working in Java for years, pick Java. It is so much more important that you feel comfortable with that language than trying to switch to something you think is going to be advantageous. And the reason that I say this is because you want to walk into that room knowing everything you can know about your language. Know what its feature set is. Know how to declare all the different data structures in that language. Know what the interface names are. Know how the types work. Know what the different string methods are. If you hesitate in the interview around any of those things, while it's a little weird to expect you have memorized those things. Obviously, if you were on the job, you would just Google things or go to Stack Overflow. But here in an interview, if you stumble on those sort of basic understanding of your language, your interviewer is going to assume you just don't code that much. And that's much more likely to happen if you suddenly pick up a new language and are trying to learn it just for interviews. So pick the language you're most comfortable with. I will have one caveat. Like I said, pick an object-oriented language. Please don't pick C. I have done hundreds of interviews. I do a lot of linked list questions. I do a lot of binary tree questions. Those are extremely common for interviewers to pick, especially for college students. And it is not going to go well for you if you do either of those things in C. So much so that I have a backup question. If my student tells me that they're going to code in C, I give them a totally different interview question. Very few interviewers do that. 9 times out of 10, I just see, unfortunately, my non-object-oriented C programmers show up and be asked to sort of, let's say, do a tree traversal, and it just gets really messy really quickly. So I strongly encourage you to at least pick an object-oriented language. The other language I would also stray away from is JavaScript. It's not strongly typed, it's not compiled, and it is not object-oriented. It's not going to have the APIs that you need. Now, if you're a boot camp person and that's the only language you've learned and you're applying for a web development position, they will probably ask you web development style questions, and JavaScript is a great choice. But if you're going in for a traditional data structures and algorithms, object-oriented programming style technical interview, you're gonna want something other than JavaScript. Now that you know what your company is, you've picked your language, it's time to get real deep in reviewing all of your data structures and algorithms. I'm going to talk about a list of topics on the next slide. and make sure that you know all of your language's API sets. Like I mentioned, make sure that you've got all of the data structures, you've got the string methods, make sure that you know what the types are, and make sure that you know how to convert between types for reasons I never really understand. Make sure you know how to convert between integer and string and back again. Those types of things come up very commonly in interviews. My favorite way to do this is when you are doing your practice problems, anytime you have to go look up an API, write it down in some doc somewhere. And then on the actual day of the interview, just go look over your notes from when you were practicing, because those are the APIs you're most likely to forget. And it's a really good sort of like in the hour or two before type of prep for your interview. My best piece of advice to be as successful as you can be is really going to come down to how much you practice for the interview. Just like we know, students that do more mock SATs are likely to get higher SAT scores. Students that do more practice problems on sites like LeetCode or HackerRank are just more likely to pass the interview. Now, this is true for a number of reasons. One, straight up being there's only so many interview questions. Now, there's an infinite array of framings of interview questions, but there's really only so many types of code that we could ask you to write in 45 minutes as somebody just coming out of undergrad. So if you do a lot of practice, there's a strong chance you are going to see a question that is really similar to one you'll be asked in the interview. And you will also, the more you practice, start to see really common patterns. You know, things like, hey, how do you find duplicates? We always sort it and then we look through it and look at neighbors, things like that. You'll start to see regular patterns show up the more you practice. The other reason too is because the interview is kind of an uncomfortable and unnatural coding environment. So you are going to want to make sure that when you're practicing, you're timing yourself. That's going to give you a good sense of if you're speeding or coding at the right speed. You want to make sure that you're practicing maybe away from your favorite computer. Maybe try writing it on paper or a whiteboard. Maybe try writing it in a notepad. Something when you don't have a compiler or the IDE that you're most comfortable using so that you're sure that you can perform in whatever scenario the interviewer puts you in. And then finally, probably the thing that feels the weirdest to practice is talking aloud while you code. Now, this can make some people extra uncomfortable, especially if, for example, verbal language is not the best way you express yourself, or maybe English is the language you're doing your interview in, but it isn't your first or native language, and you're trying to translate your thoughts into code at the same time. It's a lot going on, and while that might make you uncomfortable, the functional reality is that it's an important part of the interview that you are able to demonstrate that you have a clear process when you're attempting your code. You want to be able to explain your thinking as you go along, and we want to make sure that you have the ability to communicate about code. You're never really just going to write by yourself, so we need to know that you have the language and the way to talk about it. The other great thing about talking as you go is it's going to keep your interviewer engaged. If all you do is get up there and just write code on the board without saying anything, well, your interviewer can't help you. They're also likely going to disengage, and you want them to be your number one fan all the way through. The other thing is, a lot of interviewers, especially for students, if you get stuck or you're heading in a really bad direction, they might offer a little suggestion or a little hint. And if you're not talking or verbalizing anything that you're doing, well, then you're never going to get offered any hits. So practicing talking aloud while you code is going to make sure that you come off in a really polished way in that interview. And in fact, for some companies, the way that you problem solve and the way that you communicate can be more important than completion. I have absolutely passed students that did not complete their code, but I knew that they were going to, and they were a really great communicator, and I was able to see their problem solving techniques. So I didn't care if they, wrote the final lines of code. I still got everything I needed. Very different from, I've had students that just didn't want to talk, and so we just sat in silence for about 35 minutes while they coded. Now, if they wrote perfect code, then great. Of course, I'm going to pass them. But I can tell you that's never happened for me because it's really weird to sit in silence for 35 minutes and just code without talking to the person staring at you across the table. So lean into that discomfort, practice aloud maybe by yourself, get in the habit of practicing with friends. I know for me, it actually makes me a little more uncomfortable practicing with a friend than with a stranger. So if you're comfortable doing that, you're really going to crush it with that interviewer. All of this practice is made available on the internet. There's tons of resources out there. This channel, we're gonna have all the different practice problems. We're gonna walk through it with you, but I would definitely make sure to recommend some of my favorite resources. Check out LeetCode. It's a website that has a huge database of different coding questions, and it's tagged by topic, and it can be tagged by company. So you might want to go in and see, hey, what questions has my company been asking? HackerRank is another great platform that gives interview-style questions in a format similar to interviews. And they actually have a partnership with a really famous book you might be familiar with called Cracking the Coding Interview. I do want to take a moment and specifically call out this book. This book talks a lot about the things we're talking about here, so you might not find the content super revolutionary, but it's a really good basic. And the real secret is that almost every engineer has this book, and often we don't get a lot of time to prep for interviews, and actually very few companies have databases of interview questions, and the question you're asked probably was written by your actual interviewer, or was just the question they got asked in their interviews, which means it's probably a question from this book. Because if I have an interview in about 15 minutes, I don't have time to go prep a question. So I'm just going to open up this book and pick one out of it. So make sure that you pick up the book, but all of the questions are also posted on HackerRank, just so that make sure that you have the exposure to the questions most likely to show up on the interview. You can also find advice about interview on places like RCS Career Questions or Glassdoor, things like that. It's always good to just kind of see what the vibe is, or maybe if there's any trends in that company for their particular question set. But please take all advice on the internet with a huge grain of salt. I will tell you that while I was a hiring manager, actually one of my jobs was to regularly go on RCS Career Questions and check what students were saying about our company. And I was very regularly seeing students saying things that I just knew were factually untrue. So make sure that before you believe everything you hear on the internet, you go double check it maybe with someone you know and trust, or you can always ask the recruiter, things about the format, or if they can provide any sort of topics about what's going to be expected on the interview. Now, let's talk about what you actually need to know in terms of computer science topics to make sure that you're fully covered for anything that might pop up in an interview. Now, like I said, the question you get asked might not be chosen by the company. In fact, very few companies maintain a standardized set of interview questions. Most technical interview questions are just picked by your interviewer that day. So they can really stretch pretty broad and wide, but you'll find that what I have listed here is what's sort of considered the quote standard set of topics. They're based on data structures and algorithms courses. I teach the data structures and algorithms course at the University of Washington, and I can tell you I specifically pick topics that I know are asked on interviews and that other professors teach. And it's actually this bi-directional agreement that typically they ask questions in interviews that those interviewers learned in their own data structures and algorithms course. So this is a pretty good set. You might find something outside of it. You might see things on here that you really hope doesn't come up in the interview, but I wanted to give you as comprehensive a set as I could come up with. So our first category is just coding basics you should feel really comfortable with. Everything on this list should feel like second nature to you. Things like control structures, and I mean for loops, while loops, iterators, for each loops, if statements, else statements. Maybe you want to use a ternary statement. All of that stuff, make sure that you know the syntax. Make sure you understand the Boolean operators and how Boolean logic works in your language of choice. Make sure that you're very familiar with the data types available in your language. A classic example is that a lot of students, if they're learning Java, only know about the int as a number without decimals, but you might encounter interview questions that require a number greater than an int can hold because of the amount of bits associated with an integer in Java. So maybe you need to use a long. What's the difference between using a char or using the wrapper class, the character? Make sure that you feel very confident, especially with these types of basic pieces of data, but also how your language structures things like interfaces or different data structures or what the instantiation might be for the specific type of data you're going to work with. Other things that are really helpful are input-output features, things where you can take input from a user typed on the screen, or take input from a file, or take input from a scanner, or take input stored in an array or in a list. You want to make sure, however they've decided to communicate this information to you, you're able to parse that input and then create the output they want. So make sure you know what return types matter and whether it's returned by reference or returned by copy. Also make sure that you know how to create new files or create new scanners if that's the format that they want you to return in. All of those things are going to be great tools for your box. Also, in those moments, there is a strong chance that you will make a mistake while you're writing code. You might encounter a compiler error or an exception error. Maybe you have to do a little bit of debugging. Make sure that you're practicing your debugging techniques, like adding print statements, or also like you might have access to some unit testing frameworks, but you can't assume it. Make sure that you know how to go through your code bit by bit, commenting things out. Also, make sure that you know every single compiler or exception error so that if you encounter it, you know exactly where to find where your error is. This is going to save you a lot of time. It's a great thing to demonstrate in the interview. And if you struggle to find the bug for a really long time, it's going to get kind of uncomfortable. And it unfortunately just demonstrates that you don't spend a ton of time coding. So don't sleep on the debugging techniques. They're deeply important. Okay. Now, the classic set of items that might come in a more 300 level course or your data structures and algorithms course. This is the list of data structures I think you need at a bare minimum to be deeply comfortable with. Arrays, strings, linked lists, so nodes that are linked together. Make sure that you know how to create those nodes, or if nodes are provided for you in your language of choice. Stacks and queues, also how to implement stacks and queues using an array or a linked list. Binary trees, also binary search trees, which are just binary trees, but with the search property, the search invariant on it. Interview questions seem to be really into binary search trees. So it's just a common pattern that shows up. And then also make sure that you have some type of self-balancing tree. These aren't quite as standard, but maybe your favorite is the AVL tree. Maybe your favorite is the red-black tree. Special points if you use the left-leaning red-black tree because the code is really nice and simple, and engineers right now are really into that type of tree. Other common structures that show up in interviews, tries in a very particular set of questions, but you want to be comfortable with what a try is and what it's useful for. Heaps. I can't tell you how incredibly helpful heaps are. Now, you might be able to just use a heap in the context of your language, but also you might want to be comfortable, say, implementing a heap using an array as the underlying storage, because that's what we would be expecting you to do, as opposed to actually constructing the tree using nodes. And then the real superstar of interviews, if you learn only one data structure, hash tables. In fact, we always make the joke, if you get a question and you have no idea where to get started, just try to use a hash table. Chances are that's the solution for you. They come up in interviews all the time. You get constant time lookup, constant time put. There's almost nothing to match it. And it really will make parsing your input and creating your output a lot simpler. And then finally, it's not really, sort of a data structure, but graphs have been showing up a lot more regularly in interviews. And you should be really confident in the different ways a graph might be implemented, meaning be comfortable using an adjacency matrix, be comfortable using an adjacency list. That's probably the most popular type of graph you will be provided, but some people will make a graph object and store things inside of it, or they'll just construct a graph by having a collection of hash tables that sort of represent the graph. So make sure you're confident with all of those. Now, here's a list of algorithms that might come up. Obviously, algorithms are almost always in partnership with data structures, but you want to make sure that you know everything there is to know about how to linearly search through all of your data structures. Does it have an iterator? Do you need to use a for each loop because it's an unordered set, like a literal set or map? Or does it have indices? Also, be comfortable using the binary search algorithm, understanding its runtime, and also implementing it. I've actually had students be asked to just implement the binary search algorithm in a number of technical screens style interviews. Be confident with your graph algorithms, breadth first search, and depth first search. Usually you can pick your favorite between the two, but you might notice that some are better in other situations. And I actually have been asked, what do you think the better one is? Like, what would the difference be if you used one over the other? And I got a few extra points for being able to disambiguate. So make sure that you are comfortable with both BFS and DFS. And then, of course, the classic graph algorithms, minimum spanning trees or MSTs. Maybe you use Kruskal's or you use Prims. And then some type of shortest path algorithm. Dijkstra's will certainly be enough to get you by, but you want to be fancy and handle those negative numbers. Bellman-Ford might come in handy and kind of razzle-dazzle in the interview. The other really big category of algorithms is sorting algorithms. Engineers are obsessed with sorting. It's a little bit just kind of this cute, quirky hobby that we're all into. And so I will say it's kind of unlikely that you're going to get asked to implement just a sorting algorithm. But by knowing this list of sorting algorithms, you might find that if you know how to implement them, you can adapt them in slight ways or run them over a small subset or add a little parameter as you move through them that's going to help you solve your problem. So I would make sure that you're comfortable with insertion sort, selection sort, merge sort, quick sort, heap sort, radix sort, and bucket sort. Now, of course, radix sort and bucket sort are not generalized sorting algorithms. Those are only for numbers, but gosh darn, if bucket sort isn't really useful and a really great algorithm to build off of and adapt for other things. Similar to how BFS is kind of the foundation of a lot of the graph algorithms, picking and making sure that you have a deep understanding of these sorting algorithms might be ways that you will adapt them in your problems to come. And then finally, the list of the different concepts that you might want to be comfortable with, certainly big O notation. You will be asked what is the runtime of any piece of code that you write down, and you will be expected to refer to it in big O notation. So make sure that you know what is linear, what's constant, how do you write that down? Is it O of n squared? Is it O of n factorial? What's the difference between polynomial time and exponential time? Now, you don't have to get too deep into complexity analysis, but I can tell you that you definitely want to make sure you're confident about knowing the runtime of your own code, because the last thing you want to do is write really good code and then they'll ask you what the runtime is and get it wrong, and that being the last technical thing you say to them before you leave the room. Other things you want to be comfortable with, certainly asymptotic analysis, runtime analysis, memory allocation, and space analysis. Typically, we care a little bit more about the runtime analysis, but if you can also talk about how much memory you used and how to optimize that, and you understand the memory implications of your design, it's going to come off really well. Then the other types of sort of concepts and algorithmic ideas, be very comfortable with recursion. It's very popular in interviews. Be very comfortable implementing recursive backtracking because it's actually kind of a catch-all to solve a lot of problems. It's obviously incredibly inefficient, but for interview problems, if you just don't know how to find something or solve the problem, chances are recursive backtracking will work for you. And then by extension, if you have something that is implementing recursion or recursive backtracking, do make sure you know at least a little bit about dynamic programming, such as memoization, or maybe how to sort of reflect and do a top-down or bottoms-up approach, because that is coming up more and more frequently in interviews where they will explicitly ask you to optimize your recursive code with dynamic programming. And heck, if they don't ask you, if you just throw in some dynamic programming optimizations, they're going to be very impressed. Then I also suggest knowing a little bit about encapsulation. Make sure you're using public, private, and protected correctly so you can demonstrate good data security. Be very familiar with your language's inheritance and polymorphism rules. Now, like I said, if they don't know the language you're working in, they might not notice if you make a mistake. But for example, like you don't want to show up in Java and suddenly use multiple inheritance. They know that you're not probably coding in Java that often. Bit shifting is something that used to come up in interviews a lot more frequently. It's not quite as popular these days, and I will admit I had an interview at a time in my career where I didn't know how to do it, and I just told my interviewer that, and they switched my question. That happens sometimes, but there are certain math problems and certain incremental sort of counting types of solutions that bit shifting is super elegant for and will take you usually from that acceptable to optimal solution category. Then these are a little on the nice to have, but you will see that they come up pretty regularly, is that sort of mod or remainder math. A lot of problems require that you need to be able to determine whether something's even or odd, or how do you slice off a certain set of digits from a given int. Be comfortable using the modulus operator. And then finally, a little bit of linear algebra. Just make sure you know what the relationship is between your for loop variables, especially in the context of nested for loops. You might find that if you know a little y equals mx plus b style linear algebra, you're much more likely to get the calculations correct in how you fill out your for loops. Now, I know that is an exhaustive list, and this is definitely something you're going to want to spend a long time prepping for. You want to probably start preparing for interviews months ahead of time. People ask me how much time they should spend, and I always tell them, well, how much time would you spend to get yourself ready for a big exam? You know yourself best, but I always suggest pick a couple hours, maybe, like a few days a week, sit down and time yourself and chip away at it, because cramming all the week right before, I never see being very successful. And listen, I know every teacher says don't cram before the test. There are tests you can cram for. I write tests you can cram for. I promise you, this is not a test you can cram for. So be kind to yourself. Give yourself all the time to explore your language, explore all those topics, get ready to talk to that individual company. And I am sure you're going to shine in those interviews. With the right amount of practice, I know you're going to rock it. Until next time, I'm Casey of Kim and Casey. We got your back.